Bienvenidos, Ushamdi, and welcome CMIT 454, Section 6380 and 6382 students for the first 8-week term of the spring 2018 semester at the University of Maryland University College. This is the CCNA Security version 2.0 course, and this morning's tutorial is going to be on OSPF V3 authentication. And we're going to be supplementing the material that we talked about in Packet Tracer Activity 2.6.1.3 and the material that we did in the OSPF V2 authentication supplement. And the reason for this is extremely important. So to review very briefly, when we talked about authentication, and specifically we talked about the 3 different types of authentication that OSPF V2 provides, and that is Null Authentication, or No, and this is with OSPF V2 for IPv4. There's Null Authentication. We had Plain Text or Simple Authentication, which we know is not a good thing because we were able to capture that password being used with Wireshark, simply doing a packet capture. And then we also looked at Cryptographic Authentication, which is nothing more than OSPF V2 inserting a hash, either MD5 or SHA, into the OSPF header. And that OSPF header goes with every OSPF packet. And that is how OSPF provides security. Now, we also looked at the cryptographic authentication option with OSPF V2. But one of the things that we walked away with, one of the key takeaways, was that at no time did you see anything being encrypted? There was no encryption being used. We were simply providing integrity via authentication with a hash, and that was it. With OSPF V3, there's a couple things we need to talk about. The first thing is OSPF V3, we're talking about OSPF for IPv6. So this conversation is all around OSPF version 3 and all about IPv6. And so OSPF version 3 was a complete rewrite of the OSPF protocol. And one of the things that took place in that rewrite, right, in other words, all the code was rewritten, was that the authentication mechanism, in other words, that hash that's being inserted into the OSPF header, was completely removed from the protocol. So in other words, OSPF version 3 as a protocol inherently or intrinsically has no authentication capabilities built into the protocol, which is very different from what we saw with OSPF V2. So what do I mean by that? That intrinsically or inherently it doesn't have anything built into the protocol. Well, let's go ahead and set up an OSPF V3 adjacency. And we're going to use the same 2 routers here, router 1 and router 2, and we're going to be doing the same capture. So the enable command puts us from user exec into privilege exec. I can now go into global config, and I'm going to say IPv6, and I'll force the error here. So if I said IPv6 router OSPF 1, I should get an error message that tells me that IPv6 routing is not enabled. So I need to say IPv6 unicast routing, and then I can run that IPv6 router OSPF1 command. Now, these are OSPF V2 is still running here. Do show IP OSPF neighbor. So I can run OSPF V3 on the same router on which I'm running OSPF V2. In fact, let's see what happens if I try to set the router ID to the same value that I'm using for my OSPF V2 process. Again, these are mutually exclusive OSPF processes. They have nothing to do with each other. So I can also say, passive interface default here. And then I could say no passive interface gig 02, just like we did for OSPF version 2. So I've got it started here, right? Or I should say I've got it the beginnings of my OSPF v3 configuration set. Now let's get under interface gig 02, where to enable it, there's no network command anymore. With OSPF v3, and in fact I should probably have shown you that, so IPv6 router OSPF1, if I do a question mark, you'll notice that what are we missing here between maximum paths and passive interface? What is not here? The network command. There is no network statement with OSPF v3. So I've got to go under the interface. And I have to say IPv6, OSPF1, area 0. And this is how you would enable OSPF v3 to start the process on an interface. Now, with OSPF v2, full disclosure is you can go under an interface and say IP OSPF1, area 0, right? Or whatever area it was in and whatever the process ID number you were using. You could have done this, but I wanted to show you the network statement because as a CCNA, you will relentlessly be quizzed and questioned and tested on knowing how those network statements work under the global configuration section. So OSPF v3, we set it up the same way. We enable IPv6 unicast routing. We say IPv6 router OSPF and the process ID. And then we come under the interface and we say IPv6 OSPF1 area 0. Again, if it was a different area, we would account for that. If the process ID was different, we would account for that. But this is all we need to get things going in terms of packets being sent out on the wire. So now I'm going to kick off my packet capture here with Wireshark. And we should now not only see the IPv4 hellos, right? But what do we see right there? Let's kill the packet capture right there. So what do we see right here? FE80::1, and this address was pre-configured. It's a link local IPv6 address pre-configured on that interface that I had set up previously. And what do we see? We see that IPv6, right, OSPF for IPv6 or OSPF v3 also sends hello packets, just like OSPF for IPv4. And here's our header. There's the OSPF version, version 3. The packet type, it's type 1, which is the hello packet. We see the length in octets. We see our router ID. We get the area information. We have a checksum, the instance ID, and this is when we deal with address families, which is outside of the scope of not only CCNA security, but CCNA routing and switching. That's a conversation for the CCNP curriculum, where you can do address families. And then we have a reserve field here, which is just 00. What field, right, and this is the key point of this conversation, what field do you not see here in the header for OSPF v3? Let's take a look at the OSPF v header for v2 as a quick review. What am I not seeing over there? I don't see any authentication information. There's no field for authentication here. Down here in the hello, no field for authentication. Again, the authentication mechanism has been completely extracted, removed from OSPF v3, the protocol. And so what I'm trying to say is instead of having this authentication field in the OSPF header like we do for version 2 for IPv4, the rewrite of OSPF for IPv6 removed that functionality. It is now 100% mutually exclusive from the protocol. So there is no built-in intrinsic authentication mechanism or code in OSPF v3, the protocol. And what I'm saying is you can still do the authentication, but it's just not part of the protocol proper or the protocol OSPF v3 itself. So how do we do it? Well, we leverage IPsec. And we're early in the CCNA security course here, and so IPsec and site-to-site VPNs and GRE tunnels with IPsec, all of that is going to come later, but we're going to have a brief conversation about that here where we see how the IPsec umbrella, right, and when I say the umbrella, underneath of that IPsec umbrella, we've got authentication, we've got encryption, and now this is a game changer, right? Because before, even with the cryptographic algorithm option with OSPF version 2 for IPv4, the best that we could hope for was just simply a longer, more complex hash in the OSPF header. With OSPF v3, I can now encrypt fully the OSPF information, not the rest of the traffic, right, that's flying back and forth. And I'll do some pings and you'll see what I mean. But from an OSPF protocol perspective, I can leverage IPsec to encrypt and authenticate all of the OSPF header and packets. So all OSPF information will no longer be seen, it will simply be encrypted. And so let's dive in and let's talk about this. And we're going to do the same thing we did previously, where, let me go ahead and pull our whiteboard up here, where previously, this was OSPF v2, let's go ahead and draw a line here. Now we're talking about OSPF v3. And so with OSPF v3, there is no plain text, right? So they made some pretty good changes, right? We still have no authentication, but the types really don't apply, right? Because as part of the protocol, these aren't included. So we've got IPsec. So it's a little different, right? We're going to have IPsec, and IPsec can provide the integrity with authentication. So let's put authentication. But it can also provide confidentiality with encryption. And really, when we're talking about securing our environments, right, this is okay, this is better, this is best, and actually I don't mean to put it over there, the type 2 is best when we're talking about v2. Right? With v3, it would be, this is good, right? But this is best because I can do authentication by itself, or I can do encryption, which includes authentication. So instead of the plus sign here, let me do it like this. I can do authentication by itself, or I can do encryption and authentication. And you'll see that when we go to talk about site-to-site IPsec tunnels, right? You can do the same thing. You can do just authentication, but it doesn't make sense to do just authentication. We want to make it as secure as possible, and this is the best, is we use encryption and authentication, right? And you'll see that this is going to fall under the category of encapsulating security payload, or ESP, and this is going to be referred to as AH, or authentication header. So let's take a look at doing just the authentication header. Then we're going to take a look at setting it up to use encryption and the authentication header. All right, so how would we make that happen? And again, there are also two ways that you can do this. You can do it area-wide, or you can do it under the interface. And that's a little different, right? Because we don't need, there's going to be a single command under the interface, not two commands now. So single command under the interface or a single command under the area. So let's do it under the area first, since we are in IPv6, and actually let me get back to, do we have that there? There it is. IPv6 router OSPF 1. So how do we set it up area-wide? Well, I would say area 0, and if I do a question mark, aha, we've got some options here. Take a look at that. There's the authentication, and we're familiar with that, right? Where with OSPF v2, we set area 0 authentication, and for plain text, we hit enter. For cryptographic authentication, we said message digest. But look at this new option here, encryption. So we can encrypt everything from an OSPF protocol perspective, right? It's not encrypting the data plane traffic, right? That's the transit traffic that's flying back and forth between the links. We're only talking about the OSPF information. But let's start with authentication here. Now, IPsec, this is how we're providing the authentication. The integrity is with IPsec. And we've got this security parameter index that's going to identify this session. And we're going to take a look, because what's really going on here behind the scenes, and when we get into the GRE tunnels and crypto maps, really that's all that's going on behind the scenes, is this is creating, or it will when we do the encryption piece, you'll see, it's basically a crypto map, right? And it's going to set up an ACL for us that's going to pick off what's getting encrypted. And it's going to be OSPF, which is Protocol 89. And we'll dig into that when we get there. But that's really all that's being done here. It's automating some tasks. Now, we know MD5 is a big no-no, right? But what about SHA? Well, SHA's better than MD5, but it's still legacy. But that's all we've got. So we go with what's best between those two choices. And SHA-1 is going to be a better choice than MD5. Now, here's where we get to the string. And cutting and pasting becomes critical when we're dealing with OSPF V3 authentication or OSPF V3 encryption and authentication. In other words, protecting our OSPF V3 setup. You're going to see why. So I'm going to use my SHA-1 key, which is it has to be. That's not a maximum, right? So watch this. If I said Cisco 123, and I'll do the question mark, you'll see it says unrecognized command. If I hit enter right there, it's going to tell me there's an error. That is not telling you that's the maximum number of, or, sorry, it's not telling you that that's the maximum number of characters. It's telling you that you have to have 40 characters. So the easiest way to do this, and again, we'll keep this simple here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5, 6, 7, 8, 9, 10. And the cutting and pasting comment should be making a lot of sense right about now. So, and it's here where you can check, do I have 40 characters? All I need to do is do a question mark. Because remember, before when we didn't have the 40 characters, I did the question mark, it says unrecognized command. Now that I've got the 40 characters, I do the question mark, it says, carriage return, because there's no other options I can tack on here, because we're just doing authentication. So I throw that in there, and take a look at what happens. Crypto ISACAMP on, right? We get this nice facility is crypto, right? Syslog facility is crypto. The severity level is a 6, so it's informational. It's just telling me, hey, ISACAMP is on. Now, we don't have anything on the other side, so we're not going, or I'm sorry, did we enable do show IPv6 OSPF neighbor? Did I enable that? I did not. So on the other router, we haven't done anything yet, so we're not going to see anything right now. In fact, let me do this. It's always best to say, so I'll turn it off real quick, and we can just do the up arrow there. We'll save ourselves some time, but let's get the adjacency up. Let's ensure that this works as it's supposed to. So IPv6 unicast routing, IPv6 router OSPF1. I'm going to say passive interface default. We'll say no passive interface gig 02. Let's set our router ID just like we did to something conspicuous that when we look at it, it's like, oh, that has to be router 2. And then remember, no network command. We got to get under that interface, and we have to say IPv6, not router, sorry, OSPF1 area 0. And what we should see here is, there we go. We went from loading to full. We've got the OSPF V3 adjacency. So now when I say do show IPv6 OSPF neighbor, and the commands are very, very similar, you can see that we're good, right? We've got that dead time there. It's going to get down to 30, and then it's going to pop back up to 39, right? So every 10 seconds, we've got hellos going back and forth. But remember, in the OSPF v3 for IPv6 hellos that we have here for OSPF, no authentication information is in the header, right? And now that we know that it's working, let's come back over here, and we'll go up arrow. Whoops, and that was the no, and that was the original command. So now when I say, we see the ISACAMP is on, right? So I say do show IPv6 OSPF neighbor. Yeah, there's that dead timer and the countdown to extinction, right? Because we're going to go all the way down. We're going to miss 4 consecutive hellos, and this adjacency is going to go down. Okay, and we'll allow that to happen. But here's what we're going to do in the meantime. We're going to say do show run section router OSPF. And the reason that I did that is I want to get this. And here's that cut and paste. So the adjacency is down, right? We went from full to down, but to be expected. So I'm going to grab that and say copy and come over here, and we're about to see IPv6 router OSPF1. Why cutting and pasting is critical when we're dealing with OSPF v3. So the ISACAMP is on. The exchange is now going to take place. And there we go. We're back up, loading to full. So do show IPv6 OSPF neighbor, right? We're fully adjacent. How about a do show IPv6 OSPF interface? And let's see what we see here. Does it say anything in here about the authentication? And and there it is. Now remember, with v2, it was at the very end of this command, the output. It was at the end of the output. Here it is not. That's not the case. Here it kind of shows up right up in the beginning. And it shows us our security parameter index. Our secure socket is up. There are no errors, right? And we've got authentication is running, and it's running great. Now, let's do a packet capture. Because let's see, am I telling you the truth that nothing gets inserted into the header? Well, you can see we've got some link state acknowledgments, we've got a reply, but we want these hello packets, right? And that's what we're interested in. So let's take a look at the hello packet coming from router 1, right, being sent out. And again, the 224.0.0.5 is the all OSPF router. So any router that's speaking OSPF is going to be listening for that IPv4 broadcast address right here. This is the IPv6 equivalent, FFO2::5. Right? And again, the same principle applies, is that when you enable the OSPF process on an interface, it's going to be listening for traffic that's being I think I may have said broadcast, it's multicast. It's being multicasted out to FFO2::5. Remember, there is no broadcast technically in IPv6. But this is certainly a way to simply speak to any OSPF v3 speakers who are on the wire. Now, again, let's take a look. Here's my OSPF header, right? We've got the version 3. We know that that's the hello packet type 1, my router ID, the area reserved. Where's the authentication? Where's the hash? Where is that information? Again, it is mutually exclusive from the OSPF protocol, right? So then this begs the question, well, wait a second. If that's the case, how do I see that that's actually working? So let's take a look at this command, show crypto IPsec, and we're going to look at, let's look at SA, show crypto IPsec SA, right? So I type in show crypto IPsec SA, which is basically show me the cryptographic IPsec security association table, excuse me. And here we go. Now this is interesting. Take a look. We've got a crypto map here. We're getting information here, but we never set any of this up. But there's a crypto map that was created with this name right here. Shows me the local address, the IPsec v6 policy name. So here's the policy name. And there's that security parameter index value, right, that 256, and we'll be talking about that more. But take a look at what's happening. It says that it's encrypting packets, right, but there's no encryption taking place, right? Let's come down a little further. And we've got this crypto map, but we didn't do any of this, right? I didn't create any of this. So let's see. What if I was to say, show crypto map, and I can simply hit enter, or I could put in the name of the crypto map, which was that the interface -OSPF -map. And that will guarantee that that's going to be unique. And so really what was happening, whoops, sorry, crypto map, and did I put in, oh, sorry, interface. I can put in the interface, gigabit Ethernet 02, no crypto maps found. Yeah, I thought you could do the name, tag. Maybe it was the tag is what I was thinking. So we could do nothing, or we can say tag, and I should be able, yeah, there we go. Sorry about that. So same, if you say show crypto map and hit enter, since we only have one, we're going to see the same thing. If you had multiple interfaces that were doing this, you can limit it by simply saying tag and then putting the tag in that iOS created for us. And take a look here, right? We've got 37 matches, and that number every 10 seconds, we should see that number, 40 matches, right? It's going to continue to go up. Because as the OSPF packets are going back and forth, Ipsec authentication header information is being used. And here's our default, right? But this has been created for us by default. In other words, when we went under the show run, give me 1 second here, show run section router OSPF. When we entered in this monster command right here, underneath, behind the curtain, underneath the covers, what's really going on is iOS takes all of this information that we just typed in, and it creates the crypto map for us, and it does all of that work behind the scenes. And when I say, like, quote unquote, all of that work, right, we're going to see what all of that work is later on in the course when we're manually configuring IPsec tunnels. But just know that it's doing a lot of this work behind the scenes for us. We give it the information here, and then the parser simply takes those values that we've entered in, and it says, okay, I'm going to create your crypto map for you. I know what interface this is going to be done on because, again, we're doing area-wide authentication. We've enabled the process under gig 02. So what if I was to do this? What if I went into global config, interface, and I don't even know, do show run interface gig 01? Do I have? I've got a link local there. So if I go into interface gigabit Ethernet 01 and I say IPv6 OSPF 1 area 0, right? Remember, I've done this area wide. So every interface in area 0 should have this policy, this IPsec authentication policy provided or applied to that interface. So now let's say do show crypto map. Aha. So there's the gig 01 and here's the gig 02. So again, it's sort of protecting me so that if I enable OSPF v3 on any other interface in area 0, I'm going to be protected, and we're going to be running IPsec authentication. And so again, it's very convenient, right, that this all gets done behind the scenes. Now, this was doing it from an area-wide perspective. Remember, I said that you can do it one of two ways, just like OSPF version 2. We can do it under the global OSPF config section and the interface, or do both commands under the interface. You'll notice here, it's a single command under the global config section, and it's a single command under the interface. So let's mix and match here. Let's go ahead and go into IPv6 router OSPF 1 and do show. I'm definitely going to, and I don't think that this would work. If I was to say no area 0 authentication, yeah, it's not going to allow me to do that. So definitely cutting and pasting is going to be important here. So do show run, and we're going to get section router OSPF. Again, I only want to see, whoops, I only want to see this. And we're going to copy that, and I'm going to say no. So we're going to pull the authentication off, and we're going to paste it in here. There we go. Right, so do show IPv6 OSPF neighbor, and we're at 24 seconds, so the countdown to extinction begins. Let's see if we can get this done, though. Interface gig 02. Can I quickly get in here? And if I dropped, I think it's the same syntax. No, it's not. All right, so we're going to have to do a different, oh, that's right. We have to say IPv6, sorry. So I've got to say IPv6, and then, no, it's going to be totally different. IPv6 OSPF, I'm pretty sure. Yeah, so we're going to say IPv6 OSPF authentication, IPsec, SPI, and with the SPI needs to match, so 256, and then SHA-1. And so what could we cut and paste, right? I can still at least salvage a little of my cutting and pasting here by grabbing that. So I say copy. We lost the adjacency, but that's okay. And paste. And it didn't like that. Did I have a space? Oh, wait, I got a 40. Oh, I'm sorry. So here's what I did wrong. So fortuitous failure, right? So you'll notice that I was just dropping in the hex string, the 40. I thought what I was the 40 characters. That's what I thought that I was dropping in. But what I was really dropping in there is, remember we did 1, 1, 1, 1 10 times, 2, 2, 2, 2 10 times. It was showing me the encrypted version of the string. So what I said was, by default, I didn't have anything here after I said, I think it's SHA-1. After SHA-1, I didn't type a 0 or a 7, right? So when you do it by default, it's going to take it as unencrypted. What I needed to do, and what would have worked, is to say that, then, and boy, oh boy, I highlighted that. So one last time would have been that, and I'm thinking that this will work here, I'm hoping. Copy and paste. All right, so here's what we're going to do. It doesn't like the fact that I put, oh, it did only that. Is that what that did? So let's do this one last time. So IPv6, OSPF, and we want authentication, IPsec, SPI 256. We're going to use SHA-1, and I'm simply going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 7, 8, 9, 10. And I'm now going to do the question mark to see that, yes, that's correct. Again, I could have done the 7 and the cut and the paste, but we'll do this. And as you can see, under the interface, it worked, right? And we can, again, mix and match approaches. I could do area-wide on one router, interface only on the other. Again, Cisco's recommended best practice is interface only, is to do it under individual interfaces and to not do an area-wide configuration. Now, again, this enables authentication, and it's the crypto map that's doing it, that is mutually exclusive. It has nothing to do with the protocol OSPF V3 itself. And this is a very important distinction because, again, I come to Wireshark, let's kick off our packet capture, continue without saving, and all we need to do is stop it right there. We'll look at router 1 and take a look. Again, nothing here, right? Has nothing to do with the protocol proper, right? With the protocol itself. It is mutually exclusive, right? Remember that. That is a significant difference between V2, OSPF version 2, and OSPF version 3. So now let's take a look at encryption, because this would be the recommended best practice. Because when you use ESP, which is different than Authentication Header, or AH, you can do authentication and encryption. And that's what we want, because you don't want someone to be able to sniff the wire and get information about your OSPF process. So how do we do that? Well, the first thing that we're going to do is we're going to go ahead, we're going to remove our existing configuration, right? So I'm under the interface here. If I pull that command back and then say Control A, I'll say no. So we'll pull that off, and what we're going to see is that when I say do show IPv6 OSPF neighbor, that the dead time is under 30, and we're going to go ahead and come over here to router 1, where we're going to go under the, get into global config, IPv6, sorry about that, IPv6 router OSPF 1, and do show run, pipe it to section, router OSPF. We're going to say no, and you see I could have cut and pasted, and this, it would take that, right? But I didn't want to belabor the point over there on router 2. So copy and paste. And now we've got no authentication. And what should we see though? Now authentication's off on both sides, and there it is from loading to full. So again, we've removed the authentication. The cryptographic authentication has been removed on both sides. So we have a regular, normal, do show IPv6 OSPF neighbor. We have a regular, normal OSPF adjacency here, but again, not protected. Not protected. So now let's go ahead. We're going to take a look at the final way to approach this. And if you thought cutting and pasting was saving you time up here, wait until you see this. And again, two approaches. We can do it under the global config section, and we can do it under just the interface. And so we'll do the exact same thing that we just did. I'm going to do it here on router 1 under global config because we're already here. And on router 2, we're going to deal with it under the interface because you can mix and match. So it's very, very similar to what we just did. I'm going to say area 0 question mark, and we're not going to say authentication, right? We're going to say encryption. So we're going to spell encryption correctly. So area 0 encryption, IPsec, SPI, again, that security parameter index that allows me to differentiate between the different IPsec security associations. And so I could say 256 again. Let's use another number. Let's say 1,000, right? Let's arbitrarily pick a different number. Now, ESP, encapsulating security payload, and this is critical. This will allow me to encrypt, and here's the encryption algorithm choice. Now, okay, sorry about that. I had to edit out the browser I pulled up. It had my work email address and some email in there. So I just quickly edited that out. But back to this next generation encryption. So we come down here and we see the choices that we're faced with. We can choose triple DES, null, right, which we don't want that, or AES CBC. So let's take a look. Here's DES, right? No, should definitely not be using DES. Triple DES, that was the next best choice. Legacy, right? It's got a very short key lifetime, or that's the mitigation, is we can use short key lifetimes, have it rekey quickly. But we don't want to do that. But look at the alternative for all of these guys here. AES. And AES CBC is acceptable. The GCM mode, and we'll get into the nitty-gritty of this as we move through the course, that is NGE, or next generation encryption. That is what we want to be using. And the same thing, remember when we looked at SHA, the SHA 512 with OSPF V2, that is next generation encryption. That is what we want to be using. Here's the HMAC SHA 256. Yes, next generation encryption. And so if we come down to the little note here, that's what NGE stands for, is next generation encryption, right? That's where we want to be. All right, so back to the command line, we're going to say AES CBC. Now, we want to use again, higher the number, the better we're looking for the encryption. And this is where we're going to be entering in 64 characters. And unfortunately, we've got to do that manually right out of the gate, but we can make it quick, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 60. And then 1, 2, 3, 4. Whoops. Now, how do we check so that I didn't waste all my time, right? I want to make sure that I didn't just waste my time right here as well as your time. Throw the question mark, because if you're short characters and you do the question mark, what does it say? Unrecognized command. So we come back one, then we drop the question mark in. So remember what I said. When we use Authentication Header, AH, that's authentication only with IPsec. When I use ESP, or the encapsulating security payload, right, that does encryption, which we just set up, and authentication. So why would you not use ESP, right? ESP is the way to go because we want the most secure OSPF V3 configuration that we can have. And this is how we would achieve that. So we've got our 64 characters for the 256-bit keying material. Now, again, MD5 or SHA? Well, obviously we want SHA. And now, again, we have to put in this 40 characters for the key. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, we can check. I do the question mark. And finally, we are at the carriage return. So I've got everything set up here. And again, on router 1, we've done it under the global config section. And let's see what a dumpster fire this now looks like. So show run section router OSPF. Yeah. Boy, that is a handful. And are we losing our adjacency? Do show IPv6 OSPF neighbors. Yep, we're at 10 seconds. It's only a matter of time before this becomes an issue. Now, I'm going to quickly, and actually I can't, that's right, I can't reuse this. So we're not doing it under the area on the other side. So what I am going to grab is this. I think when we get to there, the 7, it may be a little earlier. Actually, it's going to be at the SPI, I believe. So I'm going to grab all of that. So I'm grabbing all of this in the hopes that under the interface, I can't remember it right off the top of my head, the syntax, but I think when we get to the SPI, I can drop this in and we should be good. And this, again, would also show that you can put that 7 in there, right, to say, hey, I'm giving you the hashed version of the input instead of typing, because you can see this isn't 1 2 1 1 1 1 1 1 1 2 2 2 2. It's right. It's been type 7 sort of hashed here, and that's what we're seeing. So the adjacency is down. We're dead in the water right now. Let's come over to router 2 and wrap things up. We're already under the interface. So what do we say under the interface? We say IPv6 OSPF, and there's that authentication, right? But is that what we want? No. Come a little further down. Here we go. We want encryption, and I want IPsec. And there's the SPI, and where did I grab from? I grabbed from the SPI, so my hope is that when I paste, and I highlighted the wrong thing. All right, let's do a Control U. IPv6, OSPF, encryption, IPsec. I'm back to the SPI. I'm not going to highlight that again. I'm going to copy this. This Secure CRT, the terminal emulation software I'm using, when you drag your mouse over output, it actually puts it into the buffer, and that's what it ends up pasting. So I just had to simply pull that whole command line back, go over to the other window, copy what I needed, and then I'm going to paste this in, and it's probably going to be a good idea to put a question mark, and no, it doesn't like that. And that's odd that, okay, I don't think it's going to like that because there was a 4 at the end of that. Or did it not buffer the whole thing? All right, so obviously I'm having some issues here with the cutting and pasting because it's ending right there. And that, I don't believe that is going to work. So we're going to say Control U. And unfortunately, I'm going to have to type. I got to sort my own cutting and pasting out here. So let's go ahead again. Fortuitous failure, right? Because boy, are we getting good with this IPv6 OSPF encryption, IPsec, SPI. What did we say? 1,000, 1, 2, 3. And then unfortunately, ESP. Here we go with AES CBC. And let's quickly get in the key, which is now going to be the 64 characters. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And was that 10? And now I'm questioning whether that was 10. Hold on. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. Do my question mark. All right, thank goodness. So SHA 1, and unfortunately, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. So again, the security does come at a small cost, and that cost is quite a bit of keying here for the keying material that we're putting in. Now, would you use what I used? No, you would definitely want to use something more complicated than that. And my guess is also if you tried to put that into a password cracker, because it's type 7, once we drop it in here, that it might not give you back what you think. And that may be something to look at. But again, ISACamp is on, right? So we should have here in the next few seconds, do show IP, and there it is, right on cue, right? Do show IPv6 OSPF neighbor. So the adjacency has been reestablished. But the best part of all of this is not going to be realized until we come back into Wireshark for a packet capture. And let's kick a packet capture off now, and let's look at our OSPF information. Well, there's that V4 information, right? But here's my V6. Why is it light gray like that? Why am I seeing light gray? And where's the OSPF? Why doesn't it say OSPF here? And why doesn't it say hello packet over here? So let's stop this. So here's your OSPF v4, right? This is, or I'm sorry, OSPF v2 for IPv4. So this is the IPv4 OSPF information. Take a look at this. The encapsulating security payload, we are now encrypting all of the OSPF packet information. And pay no attention to what we're seeing here with the wrong sequence. We're fine, right? Everything is fine. It's because of the way I'm doing the packet capture. So again, the key takeaway here is take a look. What OSPF v3 information am I seeing? Do I see the OSPF v3 header and then the hello packet or the link state update or any of that other information? No, I do not. Because now, not only have we encrypted it, or I should say authenticated it with SHA-1 with a hash, we are also we're providing integrity, but we're also now providing confidentiality with encryption. So if I come back to the command line here and we say show crypto IPsec SA, this is one way to see it. And I could also actually, even better way is that just dawned on me. So we'll look at this here, right? We'll take a look at, we'll scoot back up. But there's a better way actually that I just thought of. So show crypto IPsec SA, right? Again, we see the same information and we see that all the packets are being encrypted, right? And we now know that they are being encrypted because Wireshark is giving me nothing. And so this is how you would want to approach it. But the other command was, it was show crypto IPsec SA. I'm trying to remember this command, and I think it's interface. I think it's the interface. Gigabit Ethernet 02. Yeah, no, it's actually showing me the same thing. Yeah, I thought there was a better way to look at this. But yeah, the interface gives you the same thing as, and I guess it's the same as the other way. But now if we look at the crypto map as well, and I say show crypto map, take a look. We also see here that it auto-magically formulated this crypto map. And most importantly, take a look at this. Now we did not see, I don't believe we saw the ACL before. I'm curious now, when we said show crypto map before, did I just not want to talk about it then? And I think we may have lost it. Yeah, we might have lost it. So, but this isn't very important, right? Because remember, with a crypto map, and we'll learn about this, you have to identify the traffic that you're interested in encrypting. And so take a look here. Permit 89 FE80::/10. So basically, we're basically matching 89, protocol 89, which is OSPF, right? And so this is how the crypto map knows only to encrypt the IP or the OSPF v3 packets and information. And this is why all the other traffic that we saw, right? Because there's other traffic that's happening here, right? We've got a loopback message, we've got the IPv4. All of this is not encrypted. And that's why only the OSPF v3 information is encrypted. And in fact, if I was to say, and take a look at this, is pretty interesting. How about show IPv6 access list? Auto-magically, iOS took what we entered in and created this ACL and the crypto map that uses the ACL to ensure that the only thing that we are applying the encryption to, along with that authentication, is the OSPF v3 traffic. And it's basically matching it, and it's basically matching it on protocol type. Protocol 89, and look at that, OSPF v3, our SPI is that value right there that it used to create this IPv6 ACL that is named OSPF v3-1000-ACL. And this is how you would want to truly protect your OSPF v3 configurations. All right, well, this is going to wrap up the supplement for OSPF v3 authentication. Again, to quickly review, as a quick recap here, You can do OSPF authentication with, let me get the pin on here. I guess we'll do green. You can do it with only authentication using Authentication Header, right? Still IPsec, it's see that umbrella that we talked about. It's under that umbrella that you find AH and that you find ESP. And so you can do it with just authentication if you'd like, but that doesn't truly protect you, right? It does add additional protection, but you can still see the OSPF header information as well as the packet type information, right? The payload information. Or you can do what's best. You can do confidentiality using encryption and authentication, leveraging the encapsulating security payload. And this fully encrypts all OSPF V3 traffic. It doesn't help you with the V2 traffic. It'll help you with the V3 traffic, not the V2. And how many methods did we have? Well, again, we had the first method, and I'm using my mouse. Let me switch to my pen here to make this a little quicker. You can do it under the global V6 config, and that's OSPF V6 config, right? Just like we could here. You could do it area-wide, right? Area-wide. Or you could do it under the interface. And again, that's the best practice, and that is the Cisco recommended best practice. All right, guys. Well, I really appreciate your time. I'm hoping that this has really provided some clarity and some much needed detail around, because again, it's very confusing with OSPF from an authentication perspective or a cryptographic authentication perspective because of the many different ways that you can do it with both V2 and V3. So thank you guys for watching. Hope you enjoyed the video, and I will talk with you soon.